You can see that I give you a little rectangle here. Beta. You see that P belongs to beta 3. Beta 3 is a subset of beta 1 intersection with beta 2. Okay, this is the basis for topological space. Basis for topological space. Rectangles are bases. Uh, Also triangles. مثلث triangle. Okay, مثلث. This is R3, R2. R2. Okay, if I will choose a point here P, I can choose a beta 1. Okay, you see that P belongs to beta 1. If I choose here X, okay, and this is an element of beta 1, and this is another. Beta 2. Then I can choose a very little مثلث. I choose here. Look at it. Okay. Beta 3. This is beta 3. You see that X belongs to beta 3. Beta 3 is a subset of beta 1 intersection beta 2. Then the triangles is a basis for R2. Triangles is a basis for R2. Okay. In R3 space, this is R3. R3. Okay. If you choose a point here, P, okay, I can give you a sphere, kore, here. Okay, I call it P, beta. You see that P belongs to beta, kore, a sphere. Okay. The first condition of basis holds. If I choose a point here, for example X, you can see that, excuse You can see that I have, for example, this is a sphere. I call it beta 1. This is another element that contains beta 2. Okay, x, as you see, x belongs to beta 1 intersection beta 2. Okay, I can choose an very little circle sphere here, beta 3. You see that x belongs to beta 3. Beta 3 is a subset of beta 1 intersection beta 2. Then spheres, a set of spheres, is a basis for tau. Indeed, I can say that tau is generated by a sphere. Okay. I come back to the definition of basis. Okay. Again, I repeat it for you. Let I choose the color. Okay. Let X tau be a topological state. A basis for tau is a collection B of subset of X. This subset is called basis element. Such that first, for every X, there exists an element of B, call it beta, such that X belongs to beta. This is the first condition. And the second condition says that X is belong to intersection of two elements of B. There exists an element of B, beta 3. Here is beta 3. Such that X belong to beta 3 intersection of is a subset of beta 1 intersection beta 2. Okay. Some examples. Okay, this is the first examples in R2. Okay, you see that every element here, X, I can choose a circle. Okay, if Y is here, I can choose another. If here, I can choose another. Okay, every element I can choose and circle contains it. Okay, and if here this picture, if P is a point here that beta 1 and beta 2 contains E, indeed pair belong to beta 1 intersection beta 2, I can choose a circle here. You see that beta 3. you see that P belongs to beta 3. Beta 3 is a subset of beta 1 intersection beta 2. Then the circles of R2 is a basis for R topology. Okay? The set of circles is a basis for 2, and I can write 2 generated by circles. Okay. Another basis is rectangle. Mostati. Every element is here P. You see that I can choose a rectangle beta. Okay. P belongs to beta. I can choose here X. I give you another rectangle beta. Okay. X belongs to beta. Beta is rectangle. I choose here this picture. Attention. Okay. This is beta 1 here. I call it beta 1. And this is beta 2. Beta 2 is here. And they contain P. P is here. Then you see that I can give you a little rectangle. Green rectangle. You see that P belongs to beta 3. Beta 3 is the set of beta 1 intersection. Then rectangles is a basis in R2. Okay, in R2. And also I give another basis. This is triangles, مثلث. Okay, ellipse. I can choose ellipse here. Ellipse. Basic. We say basic integral. In R2, if I choose a point here, P, you see that there exist many ellipses. I call it beta. Okay, you see that P belongs to beta. For every P belongs to R. If I choose here X, for example, I can give you ellipse. Okay, the first condition holds. The second condition says that if I have P here and there exists two element of, okay, this is beta 2 and this is beta 1. P belong to beta 1 intersection beta 2. Okay, you see that I can give you a little ellipse here. Okay, I call it beta 3. you see that P belongs to beta 3. Beta 3 is a subset of beta 1 intersection beta 2. Then ellipse, the set of ellipse is a basis. Okay. Understand everyone? Understand? Okay. تشکر محمد الخفاجی. I finish my teaching here. I come back to you after 10 minutes. I finish here. Here. I come back after 10 minutes. Okay? Okay. Give a topology on R. I call it standard topology. A standard topology. Okay. Indeed, B, the basis is open interval. B belong to R. Okay. This is the basis for standard topology. B is a basis for standard topology on R. Okay, I can choose another basis. I can choose another basis here. Before I give another basis, I check that there is a basis or no. Okay. If you choose any point here, for example P, okay, you see that you can choose an interval here, P minus 1, P plus 1. Okay, you see that P belong to P minus 1 and P plus 1. The first condition holds. Okay? If you choose X here, for example, and choose two interval here, for example, this is A, B, and another, for example, this is, for example, C, D. Okay, I can give you another basis here. Attention, I can choose D and A. D and A. You see that A, D. Okay, this is an interval. I can write here X belong to A and D. This is a subset of AB intersection with C. AB intersection with C. Okay. Then the second condition holds. Then there is a basis for a standard topology on R. I give you another basis. B prime is here. A and B. From the left closed and from the right is open. Okay. A and B is the X that X little than B and greater or equal to A. The prime is another basis. B prime is another basis, and the topology generated by B prime is called lower limit topology. Lower limit topology. Lower limit topology on R. On R. On. I check for you. This is a basis. If you choose any point here, for example, P, okay, I give you P minus 1, P plus 1. You see that P belongs to P minus 1 and P plus 1. Okay. The first condition holds. If you choose another point here, for example, I call it X, and choose two basis element. For example, this is A and B, and another, for example, C and D. Okay. I can give you this one, C and D. C and D. Okay. C and D. You see that X belong to C and D, and this is an intersection AB intersection with C. Then the prime is a basis. The prime is a basis for topology of limit lower topology. Limit lower topology. Okay? Okay. Mhm. Okay. Then we have uh, uh, upper limit topology. Upper limit topology Bezegon defined by A and B from the right clause, and this give you upper limit topology. Upper limit topology on R. Okay. Then we have three topology on R. Three topology on R. For R, we have three topology. With B defined by AB, open interval, B prime, and B second. Is called, the first one called standard topology. This is lower limit topology. And this is upper limit topology. Okay. Okay. Everybody understand? Understand? Apham? تشکر علی الشهمانی محمد الخفاجی. I enable the microphone for you. If you have any question, I give you answer. If you don't like to talk with microphone or you have not access to microphone, you can write in the below car below in icon, and I read your sentence and answer to your question. Okay. Uh, okay. Okay. Subbases. تشکر عبدالسلام طه. تشکر. شكرا جزيلا. Okay. What is subbases? What is it? Okay. I define it for you. A subbasis is for a topology on X is a collection of subset of X whose union equals X. Ali Al-Shahmani, please let me, I finish my teaching. After that, I answer to your question. Okay. Indeed, a subbasis for a topology on X is a collection of subsets that union is equal to X. The topology here. The topology generated by S is defined to be a collection of all unions of finite intersections of elements of this. I explain it for you. Indeed, for example, this is topological space. Uh, uh, a subspaces is, for example, is a subset of X that such that their union, I call it Si, S alpha belongs to I. Their union is X. Their union is X. Okay. This S alpha, give you a topology. Okay. Uh, I call it tau. What is tau? Tau is union of finite intersection of Si. I from, for example, 1. Okay. Uh, 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 I delete for you the subspace. Subspace is almost hard for you to understand. I only define for you. Define for you. Okay. However, we have order topology. Order topology. What is it? Okay. Order topology. Uh, let X with this element be a all sets of the following type. One, all open interval, all open interval A, B in X. Two, all interval A0 and B. A0 is the smallest element of X. A0 is smallest in X. 3, all intervals are A and B0. B0 is the largest element in X. Okay? The collection D is a basis for a topology on X. which is called order topology, which is called order topology. Topology on okay. I must say that if X has no smallest element, okay, uh, smallest element in the case 2, smallest. If there is not smallest uh, or largest, uh, then we have not the type 2 and the type 3. Okay, only we have the first one. Only we have the first one topology. Okay, for example, I give you example in R. In R, standard topology. We have standard topology. Okay, is a order topology. Is a order topology. Okay, is a order topology. A and B. Okay, you see that A is less than B. Okay, A is less than B. Okay, we have uh, another example. The positive integer z. What is it? 0, 1, 2. Okay, is ordered set with smallest element. Is a is an ordered set with a with a smallest element. Okay, here we have 0 as the smallest element. You see that then I can define the order topology on Z. Okay, I can define the order topology on Z. How I can? Here, attention. The ordered set, ordered topology. Excuse me. Ordered topology on Z plus is a discrete topology. Is the discrete topology. For every 1 point set, 1 point set is open. If n is greater than 1, then the 1 point set n, for example n, can be written as n minus 1, n plus 1. Excuse me. I choose open interval. Open. Okay? Okay? Is a basis element. Okay? In this 1, 2, 3, 4, 5, 6, and every of elements is a basis. Is a basis. Okay. 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 I think that you are tired, and I finish my teaching here. I give you this PDF file. Okay. I teach from basis to product topology. Product topology. In the book, uh, we are in page 86. I teach before than product topology. I hope you understand all notions that I teach. If you have any question, I'm in your service. I help you. If you have not any question, you can leave the class. تشکر. شكرا جزيلا and goodbye everyone.